Okay, so this is the second video on circuits. So I don't know what happened to my data table here, but it didn't show up. So we've got three appliances, basically a refrigerator, microwave, and a stove, and we're given how much current and voltage each of them use and how long per day we're going to use them. And we want to rank them from most to least expensive. So we're really going to rank here how many kilowatts per hour they use. We don't have cost, but it would be the same for all of them. Like we would use the same power company for all of them. Um, so here we can use power equals current times voltage, and then we're going to multiply power by our hours used. Okay, so for the refrigerator, I'm going to have 4 amps times 120 volts times 3 hours a day. That's 1,440 kilowatts per hour. Then my microwave, I've got 8 times 120 times 0.1. I don't use it for very long, so 96 kilowatts per hour for the microwave. And then the stove is 9 times 120 times 0.5. And that gives me 540. So the refrigerator is going to be the greatest. And then that is more than the stove. And then the microwave is the least, because we use it the least kilowatt hours. So it has to do with how long you use it, but it also has to do with how much power they take in order to use. Okay. Which of the following would always increase the flow of current through the lights in the circuit? So remember, current and resistance are inverse. Okay, so as if we want current to increase, then we need to decrease resistance. Also, current and voltage are direct. So if we increase voltage, like if we get a stronger battery, then we increase our current. So which one of these would give us that? Let's see. We're going to X out the decreasing voltage ones, because we know that if we decrease voltage, that's not going to increase current. So increasing the voltage and increasing resistance, that would not increase current, because current and resistance are inverse. So I'm going to go with D, increasing voltage and decreasing resistance. Okay. All right, and then the last thing here is just a kind of a summary of the different rules of these two types of circuits, which is a good thing to go through. So with series, number of pathways, remember there's only one single pathway through a series circuit. What happens when one element stops working? The entire circuit stops working. Because again, they're all in one single path. So if one goes down, all of them goes down. The rule for current is the same throughout the circuit. So let's say I'm going to just pretend we've got a circuit here with 2 resistors for these rules here. So my total current is going to be the same as my current through resistor 1, and then that's going to be the same as my current through resistor 2, etc. My voltage adds up. So each resistor is going to have a voltage value, and the total of those is going to be what comes from the battery. So if the battery gives 9 volts, that 9 volts is going to be spread across these resistors. They're each going to get a portion of that 9 volts. And then resistance also adds up. So however many resistors I have, I just add up the value of each, and that gives me my total. With parallel circuits, we have multiple pathways, and you can have lots of pathways. It just depends on how many resistors or bulbs you have. Every one of those is going to give you a separate pathway. What happens when one element stops working? That pathway stops, but the rest of the circuit keeps working. Okay. Because they're all separate pathways. So that's a nice thing about parallel circuits. Rule for current for parallel, this is one that adds up. Okay, so for each pathway, I'm getting more current. That's why parallel circuits have more current overall, is because it adds up one by one by one. Voltage is all the same. And again, it's my voltage from my battery. So each pathway gets the same voltage, and that's the total from the battery. And then resistance, this is the one that's kind of weird. 1 over R total equals 1 over R1 plus 1 over R2. So with parallel circuits, the big thing to remember is that as you, two things. One is that as you increase your pathways, you're actually decreasing your resistance because you're giving your current more pathways to flow through. You're giving it more options, like traffic patterns. We talked about that. And then your total resistance is always less than your individual resistances. Again, because we decrease resistance as we add more pathways. And that's what this 1 over function does. Okay, it makes it so that your total resistance is always going to be less than those individual resistors. Okay, so that was a quick summary of circuits, and then we'll move on to electromagnetism.